Hey there, sixth graders. In today's video, we're going to go through and we're going to talk about sound energy. And in sound energy, you're going to write the notes down in whatever format you're using for your notes. So those of students that are in-person students, you guys have been using your foldables. And so you are going to be all the way down here to sound. You're going to flip up sound and you have all of this information, or I'm sorry, all this room to write the information. You literally are not going to need all of this space. That's like way too much. Okay, and there's not that much with sound. Sounds pretty simple. Many of you noticed that in the forms of energy homework that you used the book for, or the copy of the book for, they didn't even have sound in there, because sound usually is its own unit that we study, because you have to study a lot about waves. So we're going to talk a little bit about that as we get into this. But a lot of this should be review information from you, because you guys in elementary school had a whole unit on sound, and we're not really doing anything more than what just kind of going through those same concepts today. If you're an online student, you might be taking your notes in a Google slide presentation. So if that's the case, make sure that you have that open as well. Lastly, the school examples and student examples for today. For the slide for school examples, I'm not going to actually have one up there. And so towards the end of the video, I'm going to remind you to put that in. It's also kind of a little test here to see if you're actually watching the video all the way to the end, or if you're just fast forwarding to get to the parts to write down your notes. The whole point is that you're listening to me talk. The notes are important, but the explanation makes the notes make all the more sense. And so it's important to do. Okay, so let's go through and let's start talking here about sound energy. All right, so I'm not going to have you copy this slide. This is just a little bit of background information, and so we're not going to copy this in. This is information and things that you should already know a little bit about materials. Okay? And the first thing we've mentioned here over the last couple of energy forms, and that's that all objects are made up of particles. Whether it is a solid, a liquid, a gas, everything is made of particles. And sometimes it can be a single atom, but most of the time it's a compound, meaning it's different atoms that are chemically combined to form a molecule, like water or carbon dioxide, or just a couple common ones that you're familiar with. It's important to remember that in solids, the particles are really close together. They are tightly packed. Liquids, they begin to spread out a little bit more. And then the most space is in a gas, where there's lots of space in between the particles. The speed at which particles are moving is also different in all three states of matter. That doesn't necessarily come into factor in affecting sound energy, but just don't forget about that too. The particles have these characteristics in each of the states. So in solids, they're close, a little bit more spread out in liquids, and then really spread out in gases. Here's a quick little diagram of it. And again, this shouldn't be really any new information for you. But because of the space between the particles, that is going to have a factor here with sound energy as we go through this. All right, on this slide, you are going to copy everything down. Okay, so this is where you're going to be writing in your foldable or in your PowerPoint. So I'll kind of go through this, pause it if I'm going too fast, or pause it before I go to the next slide to get caught up. But make sure you're listening to me. Okay, sound travels in waves, okay? Sound travels in waves, and this is the first energy form that we're going to discuss, waves. This is another great example of why energy is really hard to talk about and understand, because even though there are lots of things in common for all these different types of energy, there's also a lot of differences. And this is like a pretty big one. The fact that sound energy travels in waves, that's way different than mechanical energy or electrical energy or some of these other things. So sound is produced when the vibrating objects cause the particles in the air to move. So sound is created through vibrations. Sound is created through vibrations. And not only is the object vibrating, but because of the object's vibration, it's vibrating the material around it. Now, normally that's a gas. It's just the air around us. The example, tuning forks, which was station number 2, probably pretty easy to figure out. In these tuning forks, it's hard to see, okay, but the tuning fork itself is actually vibrating back and forth really quickly. And it's hard to see a little bit on camera, but in person, if you were close to this, tuning forks would look blurry to you. And the reason they would look blurry is because they're moving back and forth so quickly. That's the vibration. And then that vibration of the tuning fork is causing the air around it, those air particles, to vibrate as well, and that's allowing the sound to travel in waves. The wave from this vibration goes out from one particle to the next, to the next, to the next, and expands, right, all the way through. Well, if there are particles that have to be vibrated as the wave is traveling through, that means for sound to actually exist, there needs to be something for it to travel through. In other words, what we call a medium. There needs to be matter there. And it doesn't matter if it's a solid, liquid, or gas. But it does matter if there isn't a solid, liquid, or a gas, and if there's nothing, if it's a vacuum. Because if there is a vacuum and there's not any matter, if there are not particles there for the waves to travel through, the waves won't travel. And so I'm sure many of you already know this, but out in space, where there is no air, there's no gas, it's just a vacuum of space, you can't hear sound. Because there's nothing for the sound waves to travel through. I'm sure you have life experience in dealing with how sound might travel a little different through solid, liquid, or gases. You know, sometimes it might be muffled and it might not be clear for our ears to be able to pick up those sounds, but we can still hear something, right? Even if the door's closed and you're standing outside my class, you know that I'm in here talking and teaching because I'm talking and you can hear something. You might not be able to make out every single word, but you can hear the sound. I know when I was young, I always thought it was kind of fun, like with my friends in the pool, we would play this game where we would go underwater and we would yell out like a word or a number, and then we would come back up and the other person had to try to guess what it was that they were saying. And it's really hard to tell, right? But I could still hear something because it's traveling through there. But if there's no material, right, if there's no medium, there's no particles, then those waves don't travel. All right, so then just a couple of other things here related to that with sound energy. You don't need to copy this down. You can if you want to because there's space, but this is not going to be anything that you're required to know. This is just kind of a little bit more review of some of the things hopefully you learned in elementary school. So sound waves travel the fastest through things that are easy to move. But just because it can travel faster through something doesn't mean that it's easier for us to hear it. You can still hear it, but it might not be as clear. So sound travels the fastest through solids. And think about it. Back to the first slide. If solids particles are closely packed together, then it's really quickly for those sound waves to go from one particle to the next, to the next, to the next, to the next, because they're tightly packed, right? If you're comparing water and air, sound waves are going to travel a little bit quicker through water, which is a liquid, than air, because again, liquid particles are a little bit closer than the particles of a gas that are spread out really far. And then when we're talking about sound waves can be absorbed or reflected, and different materials have different characteristics on how well they absorb sounds or reflect them. And so this would be important in a couple of different places, right? So concert halls, music halls. where we're looking for a specific sound to come in. You want the sound to be able to fill the room easily, but you don't want too much reflection or what would be called reverberation. Okay, you don't want too much of that stuff because then everything's kind of sounding mushed together and it's not clear. A great example of this is in our gym at the middle school. Those of you that have been in our gym at the middle school, if you're in a large class, it's hard to hear things. The sound just kind of all just makes this loud sound together because it's just vibrating and reflecting off of all the stuff, and nothing is really there to absorb it. Next time you're in the gym, though, look up the wall with the doors that lead you back to the hallway. There is the yellow HVAC system for the heating and cooling is up there for the heat. And you'll notice there's these like panels that are up there. Well, those panels are supposed to absorb some of the sound to take away all of that vibration and reflecting of the sound waves, but there's not enough of them in that gym to really have the effect that they need to have. Right? Lots of other places like big open spaces, right? Like churches or synagogues and things too, where there might be music or other things. You have lots of times you have wooden seats or wooden pews, not always a ton of carpet. And that's, again, so that the sound can kind of keep traveling so that people that are sitting in the back, it's easy for them to hear. And sometimes, obviously, there's music and stuff being performed at those places. In my classroom, I don't have carpet, so the sound travels a little bit further than it would in one of the other classrooms where there's carpet, because carpet's going to absorb. The tile floor is not. It's not going to absorb as much. Okay. The only other thing I didn't put on here was about the speed of sound in general. There is a sound barrier, and there are certain things like certain jets that have actually broken that sound barrier and travel faster than the speed of sound. And so we'll talk about that a little bit more when we talk about electromagnetic and light, because people talk a lot about the speed of light and the speed of sound when we talk about like lightning and thunder and things like that. So we'll get to that a little bit more next time. Okay, at this point, you're at the end of the video and you need to write in the school example. And I don't have a slide for it this time for you to pick some. I'm leaving it really wide open for you. But the school example is just going to be our station example, which are the tuning forks. Okay? The tuning forks. So, write school example, tuning forks. Then write student example. And you need to come up with your own example that can't be tuning forks. And you need to explain your student example. And then you're done with the notes for sound. All right, I'll be checking these in class. So make sure you have your foldable with you next time you come to class. Hope you have a good rest of your day, and I'll talk to you when I see you next. Bye.